Venice sinking and gradually going into extinction is no longer news because it's been sinking for a while now. What is news is how Venice is investing a sum of $7 billion to restore its pride and culture so that its unique history and charm can be enjoyed by future generations. To better understand the disheartening situation of Venice, it is more reasonable to understand the architectural design of the city. Venice had to contend with the challenges of constructing buildings and roads over an unstable seabed. As a result, the architects and engineers of the day turned their attention to the use of wooden piles, or poly, that could be driven deep into the lagoon's muddy bottom, thereby providing a foundation for the construction of buildings, squares, and streets. The wooden piles were further strengthened through a process known as calcing, where the wood was treated with lime to increase its resistance to decay and water erosion. With this process, the wooden piles could last for centuries, long enough to provide stable foundations for Venice's stunning structures. With a firm foundation in place, vertical wooden beams were erected, followed by the construction of walls, floors, and roofs. The city's buildings were then joined together through a series of small stone bridges, which would facilitate the movement of goods and people across the vast network of canals. Not only were these canals practical, but they also added to the beauty and charm of the city. The unique system of canals provided a scenic backdrop for the city and added to its identity as a thriving trading hub. Venice's construction of a canal system was a true engineering feat that demonstrated the ingenuity and resiliency of its builders. The city's foundation on wooden piles and its intricate canal network truly sets it apart from any other city. For centuries, Venice has relied on wooden stakes to build its structures, and this method has proven successful due to the wood's ability to resist decay. Typically, wood decays due to the activity of microorganisms, such as fungi and bacteria. However, the wooden stakes used in Venice's construction are fully submerged in water, which means they are deprived of oxygen, the element most microorganisms need to survive. To ensure maximum protection against decay, the tips of each wooden stake were carved off, preventing any exposure to air. But as carefully as the architects had managed to put the whole situation under control, nothing lasts forever. That's why we keep witnessing more decline in the foundation of the city. Having built a globally and viable empire, the city has become outstanding and a tourist attraction site for people all over the world. The city is low-lying and built on a series of islands and islets in a lagoon. Being around since the 5th century, it's only within the last century that the problem of flooding grew too severe. Today, the average city level has sunk 8 centimeters since 1950, with some areas dropping as much as 25 centimeters, making this an existential crisis for the city. If nothing is done, speculations are that the city could be submerged by 2100. Shockingly, the floating city differs from other cities in terms of its development. Many cities grew from their core, the center, and then spread outward. Venice, on the other hand, with numerous islands, only grew as a result of the small varying islands coming together and forming a borderless connection, whereby canals and bridges served as a connection. Why then is this architectural friendly zone sinking though? There's no one right answer to this. To answer this, many have given a myriad of reasons why the city of Venice is sinking. However, the prime reason is dredging, a process that is used to deepen canals or create new ones by removing soil from water bodies, like river channels, estuaries, or lagoons. Throughout the comings and goings that led Venice to its current status as a global tourist destination, the increase in water traffic has caused the water surrounding the city to move much faster than at any time before, eroding the soft soil around the city's foundation. Also, many believe that the increase in the growing population in Venice today has scaled beyond what was anticipated. On top of that, the pumping of millions of gallons of water from the ground for the city's infrastructure, such as the construction of numerous buildings and roads, creates a void under the city which sinks further, causing the city's buildings to crack or tilt. In light of this, efforts were made to revive the situation on countless occasions. In fact, as surrounding buildings became more and more sophisticated, the Italian government imported larger trees to be used for construction. Originally, Venice is more of a watered island than a tree forest savanna. This is why many of the wood pilings still in use today were sourced from Slovenia, Croatia, and Montenegro. These woods were strategically placed and used in a way that will make them last for decades. To make this strong enough, limestone was used to strengthen the canal bases, and the city expanded by filling the part of the Venetian lagoon with more canals and structures. All of these developments contributed to the complex maze of the city as it exists today. Its high dependence on wood is evident in how many of the iconic buildings and bridges here are made. For instance, the attractive St. Maria della Salute Church lies above the level of 1.1 million wooden stakes with more than 2 years of work. The renowned Rialto Bridge lies on a wood pile of about 30,000, and the city in general lies on oak poles of 10 million. In an attempt to build the city, the lower land, which was initially muddy and unsuitable for construction, was strengthened. Constructions were successful and carefully made to give vibrance and lasting beauty to the city. As it stands, there are places in Venice now calling for urgent attention. For example, the Rialto Bridge. Despite Venice having 4 bridges scaling through the Grand Canal to its name, the Rialto Bridge, being one, is the oldest of all. The bridge, however, was made from wood until 1588, when its stone version was designed by Antonio da Ponte, and this took 3 years of work. Blazing with amazing structures, the bridge features 2 inclined ramps, with rows of shops on either side, and there are wide staircases at each end of the bridge, leading to the top of the archway. Its arch is considerably higher than most other bridges in Venice, which was intentional to allow ships to pass beneath it. As it stands, the recent pictorial display of the bridge shows that the Rialto Bridge is now 5 or more steps underwater. The bridge is made in such a way that its wood is 60 feet in length, and since being built, it has surpassed the expectations of many. A good sign that whatever was used in making this bridge really worked. Yes, it does work. For over 500 years, buildings in Venice have been this way, staying strong and maintaining the pride of Italy. Unfortunately, the wood is now weak, and to remedy the situation comes the $7 billion investment. Due to the nature of its environs, the war against flood in Venice is endless and must be approached with all urgency. In 2019, some areas in the city witnessed as much as 7 feet of water level in some areas, while the water rose to 85% all through the city. This situation has made the city unlivable. The point here, though, is that it has been confirmed that many ground floors in Venice have become uninhabitable as a result of the penetration they suffered from the flood. In fact, the city is not as balanced as it used to be. A good way to see this is because the place is now a bit sloppy to the east. Little wonder that the northeastern city of Italy, Venice, will need some structural engineering reconstruction to stand the test of time. It's not gainsaying that most of the times of the year, Venice suffers from high water tides caused by high levels of flooding, and this is becoming more and more frequent in recent times. And in the past 2 decades, Venice has witnessed over 160 floods. All of these incidents and situations led to the introduction of the MOSE system. According to experts, Venice is one of the most vulnerable cities to suffer the efforts of climate change. This was caused due to the rising sea levels, though, and has resulted in the city sinking at a rate of 1 to 2 millimeters per year. The situation is quite alarming, but what is this MOSE system for, though? MOSE stands for Modulo Sperimentale Elettromeccanico, which translates to Experimental Electromechanical Module. This system is an engineering project that was introduced to save the city of Venice from regular flooding. It's unarguably a collection of technological locks that can block the lagoon during high tides, thereby preventing floods in Venice. Seems like a good idea, right? With 78 metal barriers that can be raised during high tides, these barriers are incredibly massive, standing at 20 meters high and 300 meters wide. Also, they work together in the water, rising and falling according to the tide's frequency. In addition, the system is equipped with sensors that detect real-time water levels, which facilitates the locking process. However, this system is one of the most expensive engineering projects in Italy's history, with an estimated cost of 5.5 billion euros from start to completion. Aside from its cost, the project is one to make headway and a massive change to the present situation of the wooden stakes beneath Venice's buildings. Just as predicted, the project has led to some controversies and allegations. As a matter of fact, in 2014, 10 people were allegedly arrested for bribing politicians to win MOSE project contracts. This resulted in 5 people being sentenced to jail, while others were fined. But the point is whether the system will provide the needed solutions to the sinking of Venice. There are various benefits to this project that the eye can see. The most significant benefit is preventing the city from sinking. Additionally, it will make it possible to attract visitors to the city and foster its economy. Before the MOSE system, yearly flooding resulted in decreased tourism and the loss of infrastructure. The MOSE system is a remarkable feat of engineering and technology that may save Venice from further sinking. It is quite evident that the implementation of this system has led to various controversies and significant expenses. Furthermore, the system remains untested, with critics suggesting it may have adverse effects on the city. As many agitate the solutions to sinking will come through with the MOSE flood control system, which will protect the city from rising sea levels and extreme climate conditions, it's estimated that this project will cost the Italian government approximately $7 billion. Well, the project is not a day-old project. This large infrastructure project dates back to 2003 when it first began. These flood barriers in Venice are made up of 78 underwater gates. Impressively, they can be closed and rendered invisible until needed to be used to block the 3 inlets to the lagoon during high tides or storms. And these have been proven effective by having deployed over 25 times since 2020. But to the shock of many, this may not come as an actual solution. The reason is the delay in launching this system to be fully operational. The issue is not the system though. The issue is, as the sea levels keep rising, there might be a need to increase the height of the MOSE to a near permanent wall. These barriers, on the other hand, can be raised to block the incoming tides and then lowered when tides recede. Looking at this from another view, some have suggested the design of the barrier and further future usage of it may affect the ecosystem entirely and hamper the marine economy of the city. With this effect in mind, another idea was to inject fluid cement beneath the city's buildings to replace the wooden stakes underwater entirely. Though this would be a great way to raise the city to a reasonable height, this has been tested on an island to be effective. Another opinion is injecting billions of gallons of seawater will make the city rise by as much as a foot. It starts from a dozen wells surrounding Venice in a 6-mile circle that will pump water over 10 years of approximately 40 million gallons. The logic is when the city is sinking, excess water can be offset into the well to reduce the excess. The MOSE system is not a totally bad idea, but other options can be considered as well. Having 2 options, or more maybe, combining the MOSE with increasing the height of the city's buildings will help to reduce the workload on MOSE, thereby saving money and rescuing the ecosystem. Though none of these systems has been implemented as of now, Venice is not to be abandoned. The city is one of the oldest, and saving it will help preserve a lot of historical heritage and tourist sites.